Megaraptors are noted for their large hand claws and powerfully built forelimbs, which are usually reduced in size in other large theropods. They are incompletely known, and no complete skeleton has been found. However, they still possessed a number of unique features. The ulna bone had a unique shape in members of the family Megaraptoridae, a subset of Megaraptorans which excludes Fucaraptor. As indicated by its slender phalanges, Fucaraptor was a relatively lightly built animal, regardless of its maturity. The immature holotype is estimated to reach 4 meters long and weigh 175 kilograms in its initial description. Its distinctive teeth show similarities with both Carcharodontosaurids and Tyrannosaurids. The holotype also had very large and flat hand claws, which played a role in its initial classification as a dromaeosaurid, as the hand claws were mistaken for foot claws, as well as its current classification as a Megaraptoran. Tratyenia is one of the youngest known genera of Megaraptorans, having lived only about 83 million years ago. It was a medium-sized Megaraptoran, growing up to 8 meters long. It was closely related to genera such as Megaraptor, Australovenator, and Murusraptor. Like most other Megaraptorans, it probably had large claws on its hands for use in hunting prey. Analysis of the Baja de la Carpa indicates that Tratyenia may have been geologically one of the youngest Megaraptorans yet discovered. Tratyenia is also the largest-bodied carnivorous animal named from the Bajo de la Carpa formation, reinforcing the hypothesis that Megaraptorids were apex predators in southern South America from the Turonian through the Santonian or early Campanian, following the extinction of Carcharodontosaurids. Megaraptorans had a unique forelimb structure, including an S-shaped humerus similar to both basal allosaurids and coelurosaurs. Their ulna was distinctive, with a well-developed olecranon and a T-shaped cross-section due to additional crests. The first 2 fingers of their hands were large, while the third was smaller, and they retained a vestigial 4th metacarpal. Their claws were large, thin, and oval in cross-section, with distinctive ridges and grooves. Their wrist featured a crescent-shaped bone similar to Maniraptorans. Recent studies from 2023 highlight their powerful forelimbs, which evolved for complex movements, aiding in prey capture. These muscular attachments became more pronounced in later genera like Megaraptor. This genus was described as a giant 8 meters long dinosaur, known primarily from a single claw, about 30 centimeters long, that resembled the sickle-shaped foot claw of dromaeosaurids. The discovery of a complete front limb, however, showed that this giant claw actually came from the first finger of the hand. The hands were unusually elongated, bearing sickle-shaped claws even more recurved than those of Spinosaurids. Mape is estimated to have been around 10 meters long in life. As such, it may be the largest Megaraptorid currently known. Members of the Megaraptoridae as a whole increased in body length following the extinction of the Carcharodontosaurids in the southern hemisphere in the early-late Cretaceous. It is hypothesized that the absence of these large apex predators allowed other theropods to diversify and fill the empty niche space. Megaraptorids then became the primary predators in their ecosystems. An analysis of known Megaraptorans shows that members of the clade in other places are much smaller. Mape would have likely had a respiratory system comparable to those of modern birds, rather than those of other extant reptiles, such as crocodilians. The generic name, Mape, references a malicious being in Aeonicenc mythology that is the shadow of death that kills with cold wind. The specific name, Macrothorax, is derived from the Greek makros, meaning large, and the Latin thorax, meaning chest, in reference to its large thoracic cavity. Some of Erostian's bones show pneumatization, air-filled spaces, including pneumatic hollowing of the furcula and ilium, and pneumatization of several gastralia. The addition of pneumatization throughout the bones of Erostean shows the evolutionary progress of the avian air sacs, which first appear as features on the sides of vertebrae, before being incorporated within bones throughout the skeleton. These air sacs would have acted like bellows, moving air into and out of the animal's relatively inflexible lungs, instead of the lungs themselves being expanded and contracted as occurs with mammals. Serrano theorized that this respiratory system may have developed to assist with regulating body temperature and was later co-opted for breathing. As mentioned earlier, the megaraptors that lived outside of South America were smaller in size. Australovenator, that lived in Australia, measured 6 meters in length and weighed 500 kilograms. It has been the subject of various studies due to its well-preserved hand and foot remains. A 2015 study found that it had highly flexible arms, with an elbow range similar to Maniraptoriforms, and a bird-like ability for its radius to slide independently of the ulna. Its fingers could extend farther than most theropods, aiding in prey capture by pulling it toward its chest. It also identified a pathology in the second toe, possibly from kicking motions, similar to modern birds. A 2017 follow-up used a 3D printed foot model to create footprints, suggesting that the controversial lark quarry trackways were likely made by a theropod like Australovenator. Ornitholestes was a small, bipedal carnivore and a coelurosaur, part of the group that eventually evolved into birds and raptors. Although it resembled early birds and raptors, it wasn't their direct ancestor, as they already existed during its time. Ornitholestes had a typical theropod appearance with a long tail, arms and head, as well as a short neck. It was likely covered in simple protofeathers, but with little differentiation from earlier species. As a Maniraptoromorph, it may have shown early bird-like traits, including potentially having elongated feathers on its arms, perhaps the start of wings. Its long forelimbs might have been used for display, while its short hind legs made it slower than other theropods. There are theories that it may have used its toe claws for defense, possibly even having a sickle claw like later raptors. While early portrayals suggested it had a crest on its snout, this remains speculative due to poor preservation. Ornitholestes had sharp, serrated teeth, indicating a primarily carnivorous diet, though it may have occasionally eaten plants, given its coelurosaur lineage. The bird-like features of Compsognathids, along with other dinosaurs such as Archaeopteryx, inspired the idea for the connection between dinosaur reptiles and modern-day avian species. Fossils preserve diverse integument. Skin impressions are known from many genera commonly placed in the group. Sinocalliopteryx was about over 2 meters long and a little less than a meter high. It was a bipedal predator, with an elongated head and pointed snout, and decidedly had protofeathers as shown in its fossil remains. It was found with the partial leg of a dromaeosaurid in its abdominal cavity, meaning that it probably ate this dromaeosaurid. It was probably an agile, active and fierce predator, feeding on smaller animals. There were irregularly shaped stones within the abdomen, which could have been gastroliths, such as those found in other theropods, in order to aid in digestion. It probably had a high, warm-blooded metabolism. Sinosauropteryx was the first non-avian dinosaur discovered with evidence of coloration in feathers, in 1996. Its fossilized remains showed a covering of simple, filament-like structures, now considered protofeathers. Through pigment analysis of the fossilized feathers, it was found to have a banded tail with alternating light and dark stripes. It also had a reddish-brown color on its back, indicating that some dinosaurs had complex color patterns. It was a tiny dinosaur, about 1 meter in length. Its small size, combined with its feather-like structures, brings it closer in appearance to modern birds than to larger theropods. Despite having feathers, it was not capable of flight. Its feathers were more likely for insulation, display, or camouflage rather than for aerial locomotion. The presence of feathers on Sinosauropteryx supports the hypothesis that some theropods were warm-blooded, as feathers are typically associated with thermoregulation. It was preserved with the remains of a lizard in its gut region, indicating that small, fast-moving animals made up part of its diet. Numerous lizards of this type have been found in the same rocks as Sinosauropteryx. First discovered in the 1850, Compsognathidae was the first theropod dinosaur known from a fairly complete skeleton, and also the smallest known non-avian dinosaur for over 130 years. Living in what is now Europe during the late Jurassic, it was a lightly built animal with long legs and a long tail, growing to around 1.2 meters long. Its hands seem to have had only 2 functional fingers, with the third being vestigial and possibly not even having a claw. Some of Compsognathidae's diet is known for certain, since preserved gut contents show it fed on smaller vertebrates like lizards and rhynchocephalians. The remains of a lizard in the stomach of one specimen were even identified as belonging to a previously unknown species, Skundsmal, with the dismembered nature of the skeleton suggesting Compsognathidae tore its prey into bite-sized chunks in a similar manner to modern predatory birds. Comparisons between the scleral rings of Juravenator and modern birds and reptiles indicate that it may have been nocturnal. However, this may be due to the only known specimen being a juvenile. A 2020 study by Bell and Hendricks noted small, round structures preserved on the sides of the tail. They interpreted these as integumentary sense organs like those on the scales of crocodiles. If this identification is correct, these would be the first sensory organs found in the skin of any dinosaur. Juravenator may have used these to detect the movement of aquatic prey, such as fish, as it waded in the water. It was originally classified as a member of Compsognathidae, but fossil evidence revealed scales on its tail and hind legs, as well as traces of possible primitive feathers. Later studies, including one using UV light, showed a more extensive covering of filamentous structures, suggesting it had a mix of scales and feathers, similar to other early feathered dinosaurs like Sinosauropteryx. Marisquia, a theropod dinosaur from the early Cretaceous of Brazil. Although known only from its hips and a few other partial bones, these pieces were so well preserved that it was given a genus name that translates to wonderful pelvis. In life it would have been about 2 meters long, but since the known fossil represents a subadult, its full-grown size may have been a little bit larger. It was probably a member of the Compsognathids, closely related to Aristosuchus, which would make it the only representative of that family currently known from the Americas. The ischium bones of Marisquia's pelvis were oddly asymmetrical, hence the species name Asymmetrica, with one side featuring a hole and the other side only having a notch in the same position. The fossil specimen also had thin-walled bird-like bones, and soft tissue impressions of intestines and a posterior air sac. Scipionix is renowned for being one of the most complete dinosaur fossils ever discovered, dating back to the early Cretaceous. Found in Italy, it represents the first dinosaur fossil from the region and includes internal organs, muscles, and bone structures, but no feathers, although as a compsognathid, it likely had them. It had elongated first fingers and a large skull with oversized eye sockets, reflecting its young age. One remarkable feature is the preservation of an air sac, highlighting the evolutionary connection to birds. Its soft tissues, digestive system, and traces of blood have been preserved, offering rare insight into its biology. Scipionix likely lived on islands in the European archipelago, where it thrived despite limited space due to its small size. Evidence of its diet shows it ate small lizards, fish, and other opportunistic prey. It had a short but efficient digestive system and may have been just days or weeks old when it died, capable of walking but possibly still cared for by its parents. Uberojara had flat, elongated spikes projecting from its shoulders, measuring 15 centimeters long. These structures were likely used for display purposes, potentially in courtship rituals, and are unlike anything seen in most other dinosaurs. The shoulder spikes were not designed for flight, as Ugueto was a non-volant dinosaur. This suggests that the structures evolved purely for social or reproductive purposes, unencumbered by the need for aerodynamic efficiency. Scientists have drawn comparisons between its display features and those of modern birds of paradise, which use elaborate plumage and physical structures for mating displays. The fossil's classification is still unresolved. Although it was initially assigned to the Compsognathidae family, there have been doubts, and the phylogenetic matrix has yet to be made available. The fossil sparked significant legal and ethical debates over scientific colonialism, as it was allegedly exported from Brazil without proper permits. After a social media campaign, the fossil was returned to Brazil in 2023. The habitat of Timimus consisted of polar forests with mild summers but cold and dark winters due to the closer proximity of the area to the South Pole during the early Cretaceous. In 1996, Unusuya Chinzami, an expert on the microstructure of fossil bones, examined bone material from Timimus and Leolinosaura and discovered they exhibited different bone histology. The Ornithischian showed a continuous rate of bone deposition, while the Coelurosaur had a cyclical pattern of bone formation, which suggested Timimus may have hibernated in colder months. The holotype thigh bone is 44 centimeters long. From this, a total length of the animal of 2.5 meters has been extrapolated. The slenderness of the bone suggests a lithe animal. It is identified as an Ornithomimosaur, but some suggest it could be a different kind of theropod, possibly a tyrannosauroid. Harpimimus is a fairly basal ornithomimosaurian from 130 million years ago, in the Albian age of the early Cretaceous. It was about 2 meters long and a little over 1 meter tall, making it fairly small. It is known from a partial skeleton and a crushed skull. It had a toothless upper jaw, indicating a shift in diet. It was best suited to gripping small animals and plants to be swallowed, making it possible that Harpimimus was omnivorous, a transitional stage in the tree, with later members possibly being completely herbivorous and having completely lost teeth. Ornithomimosaurs originated in Asia or Europe. Those that have been found in North America migrated there. Pelecanimimus is probably one of the most famous basal ornithomimosaurs, known from not only a partial skeleton but also some soft tissue. It still had teeth in its mouth, unlike other early ornithomimosaurs, giving it a bite that allowed it to cut and rip, allowing it to be a piscivore or carnivore. It was pretty small, only about 2 meters long, and it had an unusually long and narrow skull. The soft tissue preserved showed the presence of a crest on the back of the head and a pouch on its neck, much like in modern pelicans, as well as muscle fibers. Given the lack of preserved soft tissue in other early ornithomimosaurs, it is uncertain if this was a shared feature. It lived alongside many bird species, probably some Spinosaurids that it lived alongside in shallow waters, Concavenator and Iguanodon. With the first description in 1981, Garadimimus was identified as a primitive ornithomimosaurian within its own family. However, with the description of new specimens of Deinocheiridae in 2014, it was found that the latter was the sister taxon of Garadimimus, grouping within the Deinocheiridae, ornithomimosaurs not adapted for running or agile movements. The pelvic girdle and hind limbs of Garadimimus show that the musculature of the legs was not as well developed as in the fast-running ornithomimids, therefore, indicating poor cursorial capacities. It was an omnivore or herbivore with a reduced bite force that was compensated by a horny beak. Its eye sockets suggest that its good vision, a trait common in ornithomimosaurs, which may have helped them spot predators or locate food in open environments. Paraxenosaurus is known from highly incomplete remains, making it difficult to estimate its exact size. However, based on comparisons with a close relative, Baols, it is estimated to have been about 6 meters long and weighed around 600 kilograms. The holotype specimen includes fragmentary remains, but enough detail was preserved to classify Paraxenosaurus as a genus of Deinocheiridae. It has several unique features, including a deep, concave surface on its finger claw and vertically oriented presygapophyses on its tail vertebrae. Unlike many other Ornithomimosaurs, it lacks the arctometatarsal condition and retains the first pedal digit, which is only seen in a few other related species. Its tail was stiff and rod-like, limiting its mobility. Other specimens from nearby localities provided additional, though incomplete, material, but were not used to define the genus. For almost 50 years Deinocheiridae was known only from a pair of huge arms and a few small associated fragments from the late Cretaceous of Mongolia. At various times it was thought to be a carnosaur or a therizinosaur, but eventually it was agreed to be a giant ornithomimosaur. In 2013 new material was announced, although several parts of the new specimens had already been looted by fossil poachers. But amazingly a missing hand, foot and skull were recovered from a private collection, donated to a Belgian museum, and then finally repatriated to Mongolia in 2014. So after decades of mystery, we now have an almost fully complete skeleton. Deinocheiridae was indeed an enormous ornithomosaur, the largest known so far, measuring about 11 meters in length. As well as having an odd sort of hunchback shape to its spine, it also had a sail-like ridge over its lower back and hips. This may have anchored a scaffolding of powerful tendons to help support its weight, similar to those of the ornithopods. It had an unusually long, wide snout with a deep lower jaw, convergently resembling a duckbill, and seems to have been adapted to sucking up soft water plants, although it was probably also somewhat omnivorous, since fish bones and scales were found among the plant-grinding gastroliths of one specimen. The tail ended in pygostyle-like vertebrae, indicating the presence of a fan or plume of longer feathers. Rativates is a newly described ornithomimid that, rather than being named a mimic of modern paleognaths, was named a predictor of them, which makes more sense temporally. It was found in Dinosaur Provincial Park in Alberta and it is known from a partial skeleton, including the snout, and parts of the vertebrae, though many of the bones are damaged. It was an adult or subadult about 8 years old, and was a fairly small ornithomimid compared to such genera as Struthiomimus. It had unusually short neural spines on its tail, and it had a very different hip structure from ornithomimids it shared its habitat with, and it also had different foot claws, indicating that it fed on different organisms or occupied a different ecological niche than other ornithomimids. It indicates that there was a major radiation of ornithomimids in this region during the Campanian, based on its phylogenetic position. Ornithomimids were occasionally preyed upon by other theropods, as shown by a tail vertebra with tooth marks from a dromaeosaurid. One unidentified ornithomimid specimen had a pathologic toe bone, likely from an injury. Ornithomimids were probably primarily herbivorous, as many specimens have been found with gastroliths, indicating plant digestion. Their long arms may have been used to pull down branches for feeding, and their abundance suggests they were plant eaters. However, they may have also been omnivores, consuming small prey. Some fossil skulls show keratinous beaks with lamellae, similar to ducks, suggesting they may have filter-fed in water. This idea was debated, with later studies proposing they were more likely strict herbivores, based on comparisons to other herbivorous species. The presence of ridges on their beaks, seen in plant-eating animals, also supports this. Anserimimus was a medium-sized ornithomimosaurian. Gregory Paul in 2010 estimated its length at 3 meters, and its weight at 50 kilograms. The claws on the hand are long, low at the back, and rather straight, only slightly curved, with the lower surface nearly flat. The function of the powerful arm, with its straightened claws, remains unknown. It may indicate a different diet of food-gathering strategy than other ornithomimids, although its diet is difficult to determine, since the animal's skull is unknown. Scientists have long hypothesized that ornithomimids, descended from carnivorous theropod ancestors, were actually omnivores or even herbivores. It was recovered from the Nemegt Formation of Mongolia. The Nemegt is thought to represent alluvial plains containing meandering rivers. Gallimimus was a large, bipedal dinosaur, and the largest member of the ornithomimid group, growing up to 6 meters in length. It had long legs and a tail for fast, agile movement, a long neck and a slender, toothless beak similar to modern birds. Its body was likely covered in simple protofeathers, with longer feathers on its arms used for display rather than flight. Its lightweight bones, filled with air sacs, made it more efficient in breathing despite its large size. Unlike some of its relatives, it had a shorter spine, giving it a slightly squatter appearance, and a beak with ridges similar to ducks. It was primarily herbivorous, feeding on water plants and vegetation, with some evidence suggesting occasional consumption of invertebrates. Gallimimus lived in wetland environments, using its speed to evade predators, and likely lived in groups, possibly displaying parental care. Ornithomimus was a bipedal dinosaur with a body length of around 4 to 5 meters and an estimated weight of about 250 kilograms. It had a slender, ostrich-like body with long legs, a long neck and a small, narrow head, making it well adapted for fast running. It possessed a toothless beak, which suggests a diet primarily consisting of plants, although it might have also eaten small animals or insects. This beak was somewhat similar to those of modern birds, possibly for cropping vegetation or straining small food items. Fossil evidence indicates that it likely had feathers. Some fossils have preserved impressions of feathers, including simple, filamentous protofeathers. These feathers were likely used for display or insulation rather than flight. The long, powerful legs and lightweight bones suggest it was built for speed and agility. Its anatomy indicates it could run quickly, which would have been useful for escaping predators. Trackways attributed to Ornithomimus indicate that it may have lived in groups or herds, suggesting social behavior and possible cooperative foraging or predator avoidance strategies. Ornithomimus differs from other ornithomimids, such as Struthiomimus, in having shorter torsos, long slender forearms, very slender, straight hand and foot claws, and hand bones and fingers of similar lengths. The legs of Struthiomimus were long, powerful and seemingly well suited to rapid running, much like an ostrich. The supposed speed of Struthiomimus was, in fact, its main defense from predators, although it may also have been able to lash out with its hind claws when cornered. It is estimated to have been able to run at speeds between 50 and 80 km per hour. It was one of the first theropods envisioned from the outset as having a horizontal posture. Osborne in 1916 let the animal intentionally be depicted with an elevated tail. This newer view created an image much more reminiscent of modern flightless birds, such as the ostrich to which this dinosaur's name refers, but would only much later be accepted for all theropods. Struthiomimus is one of the more common, smaller dinosaurs found in Dinosaur Provincial Park. Their overall abundance, in addition to their toothless beak, suggests that these animals were mainly herbivorous or, more likely, omnivorous, rather than purely carnivorous. Similar to the modern extant ostriches, ornithomimid dinosaurs likely lived as opportunistic omnivores, supplementing a largely plant-based diet with a variety of small animals, insects, invertebrates and anything else they could fit into their mouth, as they foraged.